one is, I want to do another one of these guys. Moving my pieces of paper around for some reason. It seems sensible to me. Let's do another centenary mass question. Just one more. Just clean up the process. I've even got the answer here, so that's the one I want to do. I'm going to take this one all the way to the end, because I know yesterday I kind of did a bit and then made up numbers so that we could speed things up, but I feel I should do ones a little bit more carefully. And so this is the one I'm picking. I can't even remember which one it's the answer to now. Yes, I can. I've got it in front of me. If you're wondering which one this is like number 6 from 15.4. Once we've done that, then we have one more section to do for the test. And the test is on up to including 15.5. We're going to look at surface area. How do you find the surface of a 3D surface?
The exam isn't this week, is it?
Yeah. It's going to be on Monday week.
Oh, okay.
Right? Not Friday, the test. Monday's the test. Monday's test day, right? If you look at the syllabus, every 2 weeks test, 2 weeks test, all the way to the end. Pretty much. Right, so let's see. We've got this shape here. That's basically going to be the D. And here's our density function. It's inversely proportional to the square of the distance. So let's see if we can get that guy. We talked about that yesterday. If it's inverse, isn't it k over something? In this case, it's the square of the distance, and isn't the distance that guy? So the square of the distance, at least, is that guy. We're comfortable with where that density function came from. So what does this look like? Well, it's half a circle, starting at 5 and finishing at -5, and then half a circle, starting at 3 and finishing at -3, and it's the top half. And I think we've seen a shoot like that before. I may even have skipped by this question last time. Are we comfortable so far with the setup that we now know what D looks like, and we do have a formula for the density function? Everything's cool so far. So really what we need to do now is find M, right? And then get X bar, and then after that we can get Y bar, and we should be finished. Well, M is going to be the integral, the double integral of this particular function. Right, this is the generic, the density function, dA. That's the generic formula, isn't it, for how you do these questions. Now the density function happens to be k over x squared plus y squared. And especially when I look at what D is, and a little bit when I look at what this is, doesn't this make you think polar coordinates?
Yep.
So I'm now going to recreate the density function, which is this guy. And it's going to become basically just k over r squared. Are we happy with the k over r squared? Where? This guy. This guy. Now, that means that M is going to be a double integral using polar coordinates of this fella, r dr d theta. Now, the r goes from 3 to 5. What does the angle theta do to generate this shape?
0 to pi.
Agreed. If it was an entire donut, wouldn't it be just 0 to 2 pi and all the other combinations that you could get? So we basically set this fella up. This is variable separable, which just means you can, I'll give this guy the k. And these partially cancel. What do I have? Go check something here.
Yeah.
It's not the square. It's the square root. Oops. Which actually makes this question a lot easier to do. It wasn't the square root of the distance, it was the square root of the distance. I mean, I could have done it with the value I'd got, but then it wouldn't match question 6. This fella here, can I tell you it's 2 pi? And this fella here, can I tell you it's 2?
Wait, isn't that just the distance formula?
Yeah, essentially. Yes, short answer. So 2 pi and a 2. And I said 2 pi, and nobody even told me I got it wrong. There we go. 0 to pi of k is pi k, and 3 to 5 of 1 is 2. Put them together, 2 pi k. It's me getting my usual distracted self. Okay, so we got this m fella. I need to get an x bar fella. And he's going to be from 0 to pi as well. And he's going to be from 3 to 5 as well. And the density function is this fella, right? How do you get x bar? What's the formula for x bar? You have the density function, right? But what else do you have in front of it?
We have an x.
You have an x. So that means it's going to be 0 to pi, 3 to 5. X is going to become r cos theta. This fella is going to be 1 over r. And then you're going to go r dr d theta. Are we cool with that? X is r cos theta. Density function 1 over r. The dA is r dr d theta. And these are the limits of integration. If I split this up, and where's my k? There we go. I can give this guy the k again.
And don't you also need the 1 over the mass?
I hope I did it when I did the k over r. So that's the thing, k over r. Oh, the 1 over mass. I know what you're talking about. Yes. My brain is thinking, although you can't tell what my brain is thinking of the next section. I've got to get that out of my head. Surface area. Focus on this before you go too crazy. Here we go. Looks like the r is going to go here, and this guy's going to get cosine theta. And there's the split. Let's check if I did it. These two cancel, so there's an r left over. There's a k cosine theta, which I decided to give to this guy. And I'm going to make my life dead easy. What's the integral from 0 to pi of k cosine theta, d theta? It's a very easy number. The integral from 0 to pi of k cosine theta.
0.
Yeah, so that whole thing is 0. If you know something's 0, why bother doing the rest of the work? So we now know that x bar is 0. Y bar is 1 over m, the integral from 0 to pi, 0 to r, but y rho dA. That's going to be 1 over the 2 pi k. Theta equals 0 to pi. R equals 0 to 5. Y becomes r sine theta. K over r dr d theta.
Wouldn't R be 3 to 5?
Did you all catch that deliberate mistake? 3 to 5, yes. So this is going to be theta equals 0 to pi. I'm going to give this guy the k and the sine theta. This is going to be 3 to 5, and that cancels with that, and I'm going to get r dr. Let's check I got that right. Sine theta with a k, gotcha. Cancel 1 r left over, gotcha. 3 to 5, yep. 0 to thingy, 1 over 2 pi. We are cooking. Right, this fella here is 1/2 r squared from 3 to 5. And if you do this fella here, you'll get, well, what do you get? What's the antiderivative of k sine theta?
Negative k cosine theta.
Yeah, correct. Negative k cosine theta from 0 to pi. So that's going to be negative k cosine pi, take away negative k cosine 0. This fella here is going to be 1/2 25, take away 1/2 9. Let's see what we get here. 1 over 2 pi k. Cosine of pi.
That's -1.
So negative makes that a plus, so that's a k. 2 negatives make that a plus. Isn't the cosine of 0 also 1? So you put that package together, are you happy with the 2k? That's 25 halves. Take away 9 from 25. I believe that leaves you with what, 16? And 16 halves gets me 8. And that cancels and that cancels, and it looks like 8 over pi is what's left. Cancel, 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 cancel. And so y bar is 8 over pi. So the center of mass of this shape is 0, 8 over pi, and I am really happy because you lot kept me in the straight and narrow. That is actually the right answer. So I didn't screw up too much. But it is easy to screw up, right? So you be careful. So are we comfortable with that process? The thing I find relatively nice about that group of questions is that it's quite plug and chug, isn't it? A process. This is what you do to get m. This is what you do x bar. This is what you do y bar. As long as you're comfortable with finding integrals or converting them to polar and finding integrals, there's not too many twists in those kinds of questions. Great. So what we're going to look at for our next section is surface area. And it has a formula. So it is in a lot of ways a plug and chug situation. So let's try and imagine what the thing looks like. Can you imagine? No good. Try again. Okay. Can you imagine that that is a 3D surface? It's like a cap. Now, can you imagine that you have a region on the bottom that might be rectangular, but it could be any shape you like. And if you project that up to this shape, that what you end up generating is a little curved surface that might look something like that. We are going to find the area of that curved surface. So imagine you've got your normal Z guy, right? This fella here. Z equals f of xy. You got this guy in the bottom, call him D, right? This guy projects up to the surface, and what you get is like, imagine somebody cutting out a piece of material and then finding out what the square meters, how much area that piece was, and that's what we're trying to calculate. And the formula for getting the surface area, A of S, is the double integral over this region of this weird square root guy. In fact, that number 1 isn't as strange as it seems. Technically, that number 1 is him. So, partial derivative with respect to x, y, and z, squared and added together. We're comfortable with living with the magic of this is the formula that does what we need. So what we basically are going to be going through then is, here is a surface, here is a D, find the surface area. Now, if it's a really nice question, that's exactly what they'll tell you. And then sometimes they're going to make it a little bit harder by not quite telling you what D is. And you have to kind of find it. And sometimes they're going to do a question where maybe it would be better to do it in polar form rather than dx, dy. Well, we're kind of comfortable about questions now when polar comes out. Wouldn't polar come out if this region was curved, circular, you know, a disc, you know, that kind of thing? We'd probably do the question in polar. So that's kind of what we're going to be doing for today and tomorrow. They're quite long questions, but that's fine. Let's jump right into it. This is like question 1. So we're going to take a surface, 5x plus 2y plus 4z equals 65. And we're being asked to find the part of the, this is the plane, and we're looking for the part of the plane that lies in, oh God, first octant. Oh. So what on earth are we looking for? Well, this one is giving us a disguised, they're not telling us D directly. What they're saying is it's in the first octant. So let me tell you where the first octant is. Can you imagine 3D shape with the 3 axes in it? Do you know, like in good old fashioned first, second, third, and fourth quadrant? When you do 3D, do you know there's 8 octants? And the first octant is this one here. That's where the X's, the Y's, and the Z's are all positive. So we need to find out, what does this shape look like when you're talking only in its first octant, right? In the place where this plane lives. So can you imagine this plane, I'm doing it with my hand, cutting through the shape. What would it look like when it hits the ground? Because isn't D the ground? That's where D lives. So I'm going to have to find what D is by first figuring out what the region on the ground is. When you're on the ground, isn't Z 0? So what we have is 5x plus 2y equals 65. So the region on the bottom, the guy that we have on the bottom, is this fella. And I wish I'd picked better numbers, but too late now. That's D. That's what 5x plus 2y equals 65 looks like if you keep it in the area where x and y is positive. Are you comfortable about where the 13 has came from and where the 65 over 2 has came from? All right. Now, this equation is now going to be rewritten as y equals 65 halves, take away 5 over 2x. So that's the straight line. I just rearranged this guy. So this question, the hard part was getting the D. I now have the region D. So I want to find the surface area. Oops. And while I'm at it, I'll write the other guy up here so I won't forget him. So it is going to be the double integral over this region D of the square root of 1 plus this guy squared plus this guy squared. Yeah. Right, let's see if we can fill in some of the gaps. This equation is no use. In the way that it's written, I can't use it. Don't I have to rearrange this into z equals? So 4z is 65, take away 2y, take away 5x. That makes z 65 quarters, 2 quarters, that's a half y, take away 5 quarters x. So now I'm ready to do what I need. To describe region D, won't the x go from 0 to 13? Won't the y go from 0 to its equation? Square root of 1 plus, if you differentiate this equation with respect to x, you get negative 5 quarters squared. If you differentiate this equation with respect to y, you get negative a half squared. So our integral is going to go from 0 to 13, 0 to this ugly guy. Yes.
Robertson, wouldn't the shorter way be to just find the square root and multiply it by the area of the triangle? Like,
oh,
just drew. Yeah, that would be a quicker way.
Right, so say that again so I can get in my mind what you're saying.
So find the square root, which you're doing right now, and then multiply that by the area of the triangle you just...
Yes, that will work totally fine. Yes. I'm just taking you through the mechanics of this process, but what you said is a nice shortcut. That works really well in this particular situation. That technique doesn't work so well in the later ones. But if you're catching what he's saying here, basically what you can do is you can find the area of this triangle multiplied by this. Why is that the same thing? Well, see if I take this away and just put in a 1, this double integral ends up being the area of that triangle. Because isn't an integral of 1 the area of the thing? So that's what Reese was noticing, which is cool brain. Did you see that yourself or did you read that?
I saw it myself. Well, just read it.
Yeah, bang on. Very cool way of doing it. So if this shape here, so let's just dwell on what Reese is saying here. If this D area is a nice shape, right, something you can calculate, like half a circle, right, something like that, you could do that. But, and it's a big but, that only works when this square root thing is a number. If this square root thing ends up being the square root of x squared plus y squared, right? Something like that. Don't do it, right? But it's cool when it does work. Oh God, what's this going to be? I wish I thought this one ahead. It's going to be 25/16. It's going to be 1/4, which is what basically 4/16. That's going to be 16/16. That's 20. That's 45/16. And at this point, I think I'm just going to go ... Would you agree it's pretty mundane? And if you want to do what Reese says, can't you just find the area of the triangle and multiply it by this guy and make it look pretty? Before I move on, if the square root thing is a number, as it would be in this particular made-up question, you could just find the area of this shape times √10. So basically you go √10 times the area of that shape, and you'll be done. So if you're not a visual person, well, if you are a visual person, that's what's going on there. Okay, so let's see if we can do one. I think this time I'm just going to use the numbers in the question, because evidently when I randomly pick numbers, they just go really ugly really quickly. So our next fella in our list is going to be question it's going to be question 3. We're being asked to take the part of a sphere, which is x squared plus y squared plus z squared equals 25, that lies above z equals 2. Can you imagine this is the xy plane, and that's half my sphere, and that's my z-axis, right? Can you imagine if you cut this shape at z equals 2? What you're getting isn't an entire half a circle, right? Or half a sphere. Aren't you getting just a little bit that's left over on the top? Right. So our surface area is that piece there. So step 1, we got to find D. You know, we got to find out what the floor looks like. And the floor is going to be, actually, see if you cut that shape, won't it just be a circle? If you cut a sphere horizontally, don't you just get different shaped circles? So let's find out what that circle is. Well, it's going to happen when these two things interact. So it's going to happen when x squared plus y squared plus 2 squared is 25, which means it's going to happen at x squared plus y squared equals 21. And yep, that's a circle. Agreed? And the circle that we're talking about is this fella. And would you agree that it's a little bit awkward? Its radius is √21. Am I going to do this question XY, or do you think I'm maybe going to go polar on this one?
Definitely polar.
I would say definitely polar, right? So the area of the surface is going to be the double integral of this guy, and I'm just writing this formula down as many times as I can so that it might stick in our brain. Now, if I need to do this formula, which I do, and I do have to convert it to polar, then I've got really 2 separate jobs to do. The polar part is probably going to be the easiest. Would you agree that theta is going to go from 0 to 2 pi, and r is going to go from 0 to the square root of 21? Would you agree for a basic circle, that's not an issue? So what's the second piece of the puzzle? Well, there's going to be an r, dr, d theta over here. I need to find out what these guys are, and then I need to convert them into polar. right now, the equation that you have given is this fella. But to be able to calculate this, don't we have to convert this fella into a z equals form so I can do the partial derivatives? So I'm going to do that as a side issue. And I'm going to show you two different ways to do that. Version 1 is basically the way that most people would tackle it. Would be that way, right? Great. Now, if you want to differentiate that, you probably should write it like that. And so to get the partial derivative with respect to x, you multiply by the power, you reduce the power by 1, and then you differentiate what's inside with respect to x, which gives me this. If you tidy it up a little bit, that's what you end up with. I guess I've skipped a couple of lines, but can you imagine the extra lines I've skipped? Now, I don't want to do that again. Would you agree that I should be able to, just by using symmetry, figure out what the other answer is without actually doing it? Right, so tell me what the other answer is going to be without actually doing it. Just tell me the answer.
Negative y over the same thing.
Right, That's cool, right? And that is method 1 and makes perfect sense and it works. But I said I was going to show you two. And once I show you this method, you can decide to, yeah, I like it, I'm going to use it, or nope, I don't like it, in which case you're just going to do it this way and everybody's happy. I'm not going to touch that at all in the second method. I'm going to do a partial derivative with respect to x. Well, if you do this guy with respect to x here, you get 2x. If you do this guy with respect to x, you get nothing. If you do this guy with respect to x, you get 2z dz by dx. And if you do 25, you get nothing. It's called implicit differentiation. You remember doing that in one of the earlier sections where y is considered a constant, but z is considered a function of x, right? So they're treated differently. Now, if you rearrange this fella, can you imagine that you'd get that? If you simplify this fella, can you see that you get that? And isn't z the square root of 25 take away x squared take away y squared? In other words, the answer. Do you see that's just two roads to the same destination? Right? So, some people like that. I don't know why they like it. Me personally, I don't have any preference. But some people like this method a little bit different than that one. Maybe there's less square roots in generals. Maybe that's the reason. But it works. So it works, right? You can use it. Now I've got to put all those bits and pieces into my poor package, which is over here. So it's going to be 1 plus this guy squared. Well, let's just square him. If you square him, don't you get x squared over 25 take away x squared take away y squared? And the other one, don't you get a y squared over 25 take away x squared take away y squared? That is a one ugly looking guy. And he's in x's and y's. And we know that we're going to go polar. So I've got a lot of work to do here. So I'm going to do it at the side again. we're going to have to do an awful lot of quite messy algebra. But hopefully when we're finished, something nice is going to come out of it. If you want to add things together that are fractions, don't they all have to share a common denominator? That means this number 1 is going to become 25 take away x squared, take away y squared, over 25 take away x squared, take away y squared, plus this guy, plus that guy. Dot, dot, dot is the same thing, right? I just don't want to have to write it all the time. Which means I can now combine them into one fraction. This plus this gets me 25. It's a little bit nicer, right? A little bit. Let's make it polar. How do you write the bottom in polar form?
25 minus r squared.
Great. Let's put it inside a big square root. Five on the top. No, you cannot call the bottom 5 minus r. If you're hoping to do that, don't. It's not allowed. So we now have the integral theta equals 0 to theta equals 2 pi, r equals 0 to r equals the square root of 21. This whole package has been converted into 5 over the square root of 25 take away r squared, r dr d theta. Is this a variable separable situation? So I'm going to do the integral from theta equals 0 to theta equals 2 pi. I'll give it the 5. And that leaves me with r equals 0 to the square root of 21 of r over the square root of 25 take away r squared dr.
U sub, right?
Yep. And who's the u sub?
25 minus r squared.
Right. Can I dot, dot, dot this? Because I think we broke the back. You agree at this point, it's just Calc 2 stuff. Do you see how ugly the process and the algebra was in this question? It isn't a clear 4 lines, tick the box, move on. There's lots of little, I have to do this bit of working on the side just so I can make that nicer. I have to do this bit of working so I can find out who D is. I have to simplify this. I have to convert that into polar. There's all of these little sub jobs that you need to do, but you need them because each part fits together as part of the bigger picture to eventually get you whatever this comes out to be.
No, I've learned in each like subsequent math class, the harder it gets, the harder basic algebra seems to get.
Yeah, the algebra never leaves, does it? It just gets uglier.
Yeah, same with trig.
Yeah, trig never leaves. It just gets uglier. Quite a long question, but that's fine. Questions take as long as they take. Got time for one more then. While I'm getting this set up, do you want to say hi so we can take attendance? This one is going to be similar to question 5. (3x plus 2y plus z equals 6. And this time it's inside a cylinder, x squared plus y squared less than or equal to 9. The good news is I do not need to figure out who D is, because that's what this is. So can you imagine that there's a sloping plane and there's a cylinder coming up? Wouldn't that be an ellipse? Can you imagine a flat plane and a cylinder like doing the little cut thing? That would be an ellipse. So we have a circle, radius 3, that's D. If I rearrange this guy, it's not anywhere near as ugly as the one I did. You see why you should pick questions from the book. Much cleaner. So I'm pretty much ready to go here. So the area of the surface is equal to, oh, let's put you in the spot. Don't look, straight out of memory. What's the formula?
1 plus dz dx squared plus dz dy squared.
Right, that's the generic formula. Would you agree that they seem to like polar a lot, don't they? We seem to get a lot more polar questions and just, you know, leave it alone XY questions, but that's fine. We've got a nice polar question. We can deal with that. Theta goes from 0 to 2 pi because it's a whole circle. And R goes from 0 to 3. R dr d theta. And differentiate this guy, you get -3 and you square it. And differentiate this guy, and what do you get? -2 and square it. Oh, we got lucky here. Isn't that a normal square root? Just a number? Remember what Reese Witten said? And I said, look, as long as this is a number, can't we bypass a lot of the work? Because isn't it just this area times root 10? And the area of this circle is pi times 3 squared, which is 9 pi. Right, pi r squared. And so we would get 9 root 10 pi. And I can't count. Root 14. I had a look at the answer. That's what reminded me. So, I guess the moral of this story is some questions can be really easy, and some questions you have to fight your way through. And I think the separation is if this square root ends up being a number, you're looking at an easy one. And if this square root has anything in it, x's, y's, just needs one of them, then you have to go the hard way, right? You have to do all the extra work because there's no shortcut. Are we good? Right, well, I'm going to call that a day. I'll see you all tomorrow. And we'll just fight our way through some more. Okay, bye-bye, everyone.
Bye.
Hi, James. You got a question or are you just hanging in? Nope. Bye-bye then.